B says, using a scale of 2 centimeters to represent 5 units on both axes, draw a histogram to represent the distribution of prices. For 5 marks, using a scale of 2 centimeters to represent 5 units on both axes, draw a histogram to represent the distribution of prices. So, graph sheet now. Alright. First thing, it's my histogram. I'm going to share something to you about the histogram. So the histogram, the values you use to plot the histogram are your, use the upper class boundary and use the frequency. The values you use to plot your what? Histogram are the upper class boundary and the frequency. The histogram is going to look something like this. The histogram is going to look something like that. This is your histogram. So, upper class boundary and what? Frequency. Upper class boundary and frequency. Alright, so these are the values I'm using. Upper class boundary, frequency. So 4.5 corresponds to a frequency of what? 2. So 4.5, 2. Then what? 9.5, 5. 14.5, 12. 19.5, 18. 24.5, 9. 29.5, 3. And what? 34.5, 1. Those are the points we're going to plot to draw our histogram. Those are the points we're going to plot to draw our histogram. Next, 1 centimeter from the left margin, I want you to draw your vertical axis. 1 centimeter from the left margin, draw your vertical axis. One centimeter from your left margin, draw your vertical axis. Then I want 1 centimeter from the bottom margin, draw your y-axis. Draw your horizontal axis, sorry. So, over here is frequency. Down here is the upper class boundary.
You said 1 centimeter horizontal, sir?
1 centimeter from the bottom, horizontal. 1 centimeter from the left, vertical. What else about it? When you write the word frequency and upper class boundary, don't write it too close because you're going to leave numbers in the space between them.
Sir, what if you draw the line like that? It's not even with the line on the graph where you mark?
You should draw your axes on a major grid line. So you can't draw it on and off, you must draw it on the major grid line.
Is it also 1 centimeter, sir?
Yeah?
It wouldn't be on the major, it's 1 centimeter.
Yes. The major grid lines are 1 centimeter apart. So yes, it will still be on a major. That in between one is major. No, 1 centimeter. 1 centimeter.
You know this one, sir?
Yeah, this is 1 centimeter.
Yes, sir.
Just line up and draw it down.
But it's the line.
Yes, that's it.
That's what I'm saying.
It's major. Alright. Scale. The scale is 2 centimeter to 5 units on both axes. That means every 2 centimeter, the number goes up by 5. Watch me. 0. 1 centimeter, 2 centimeter, 5. 1 centimeter, 2 centimeter, 10. 1 centimeter, 2 centimeter, 15. 1 centimeter, 2 centimeter, 20. 1 centimeter, 2 centimeter, 25. 1 centimeter, 2 centimeter, 30. 1 centimeter, 2 centimeter, 35. The scale on the vertical axis is the same scale on both axes. So it's what? Every 2 centimeters the number goes up by 5, 10, 15, 20, 25, 30. Alright. So to the vertical axis is frequency. The highest frequency of is 18. So your graph is not going to go higher than 18. Alright, next. The next thing is that we need to find out what is the value of each minor division. What is the value of each minor division? No. Alright, answer this. Every centimeter in the graph sheet is divided into how many equal parts?
5.
5. So 2 centimeters would be divided into how many equal parts? If 1 is divided into 5, 2 will be divided into how much? 10. But this 2 centimeter represents what? 2 centimeter represents what?
5.
But the 2 centimeters divided into how much?
5.
It's divided into how much?
10.
10, don't it? 2 centimeters divided into 10. So the 5 unit is divided into how many equal parts?
10.
Watch here. This is 5, don't it?
Yes.
That's how much it divided into. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 5 unit is divided into how many equal parts?
10.
10. Let's get the value of one part. So you divide 5, 1 minor division. You divide 5 by 10. Each of them is what? Is a half or what? 0.5. Here's what that means. Watch this. Each minor division here so is 0.5. So watch this. 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. Then 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5,
10.
so down here, so where is 4.5? It's just before what? 5. Where is 9.5? Just before the mark, just before what? 10. Where is 14.5? The scale is the same on what? On both axes, don't it?
Yes.
Fine. Alright. So let's plot some points now. Hold up your head a little. Hold up your head a little. Because after we finish, you can go and tidy up your own. First point, I'm going to finish the question, understand? And then you guys can finish up. First point, so just watch me for the time being. And then when you understand, you can ask me any question. 4.5. We already established that 4.5 is just before what? 5. 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. 4.5 is just before 5. So 4.5 vertical corresponds to 2. So vertical no, horizontal no. 0, 0.5, 1, 1.5, 2. That is my first point. The second point is what?
9.55.
9.55. Where is 9.5?
The mark before 10.
Just before 10. 9.5 go up. Corresponds with 5. That's this point here. 15.5. Where is 15? 14.5.
14.5 is before 15.
And that corresponds to what?
5. 12.
12. So 14.5. Let's get 12. 10. 10.5. 11. 11.5. That's there. 19.5 corresponds to what?
18.
19.5 just before what? 20. 15. 15.5, 16. 16.5, 17. 17.5, 18. 24.5 corresponds to 9. So 9 would be what? Below 10 you have what? 9.5 and then what? 9. This is 9. And 9 corresponds to 24.5. That's there. 29.5 corresponds to 3. 29.5 is here. And 34.5 is here. 3. So this is 2, 2.5, 3. Which is here. And 1. Which is there. Now everybody knows that you must not draw these dotted lines, don't you?
Yes, sir.
You must just plot the point. And you have to be careful because the lines are what? Are fine. You understand? You usually need good eyesight. So if you look on the paper and it's blurry, you probably need to get glasses before the exam. Or walk with what? Reading what? Glasses. You understand? Or with a what? Magnifying what? Glass. You understand? If it is you look at it and it looks blurry, it means the eyesight might be bad. As I said, let me finish the question and then you can ask me any question. Please look. I want everybody to look. Now, I'm going to what? Show you how I would draw the histogram. I would start from this side. The last bar, the height of it is 1. That's this bar here. The height of it is 1. And it ends at what? 34.5. It started at what? 29.5. The bar before it, the height of it is 3. Starts at 24.5, ends at 29.5. The bar before that, the height of it is 9. You all know that this must be done with a ruler, right? It must be done with a ruler. The one before that goes up to 18. The one before that, and the one before this goes up to 9. You have to be careful when you're doing it. You have to be careful when you're doing it. The one before that is 5. And the very first one is 2. I need for you to look carefully, because there's a little issue where the first one starts. There's a little issue where the first one starts. Let us, you see when you follow this thing, there's a pattern to the thing. This one starts just before what? 13. This one starts just before what? 25. This one starts just before what?
20.
This one starts just before what?
15.
This one starts just before what?
10.
This one starts just before what?
5.
So the first one would start just before what?
0.
0. It does not start at 0, it starts just before 0. The bars must all be of the same width. The bars must all be of the same width. To achieve that, this one must start just before what? 0. And the height is 2. The first one starts just before 0, and the height is 2. Alright? Ladies and gentlemen, that's what your histogram would look like. If I wanted to, if I could erase some of these, just to give you a better picture of it. It starts just before the origin, which is at 0. Alright? And just erasing some of these to give you a better picture of the histogram. The histogram looks something like that.
So you start before 0 after 0, sir?
It starts just before the 0. Just before the 0. It starts here.
Yes, sir.
Minus 0.5, which is before 0.
Yes, sir. That one after.
No. This is before 0, this is after 0. Before 0, after 0. It starts before 0. 0 is this line, you know.
Yes, sir.
So it starts before 0. Watch me. All the bars must be of the same what? Width. I told you, let me finish the question. I want to answer C. Then you can ask me any question you want. Here's what C says. C says, estimate the probability that a worker selected at random would spend at least $20 on lunch. Here's what I would tell you. I would tell you that at least is an inequality term. At least. It's an inequality term and it means greater than or equal to. At least is an inequality term and it means greater than or equal to. So when someone says estimate the probability that someone selected at random would spend at least $20 or more on lunch, what they're asking you for, see, the probability that the cost of what lunch is greater than or equal to what? $20. Let's find out. Look at the table, come back to your table. Tell me, how many persons lunch costs either $20 or more than $20? From the table, how many persons lunch costs $20 or more than $20?
13.
Talk to me.
13.
Mufat is correct. It is 13. Those 13 people. These 9 people, their lunch costs between what?
$20 to $24.
So that is more, that is 20 or more than 20, don't it? Them people for them on what?
25 to $29.
These people,
30 to $34.
which is more than what?
20.
So how many persons lunch costs $20 or more?
13.
13 out of how much?
15.
The probability is 13 out of what? 50. Or 0.26 or 26%. There's a 26%. If you select a worker at random, the cost of their lunch is going to be $20 or more. There's a 26%. If you select an employee at random, that the cost of their lunch will be what? $20 or more.